with all those things. But first thing I have to make them convince, and then I have to implement it. In the morning session to say having the idea is easy, but to getting it implemented, accept it, and then implement, that's very difficult. So that's why I have just made it all those things. What is the meaning of the greenness of the industry? Number two, and then how whatever the growth is coming will be sustainable over a long time, and then how the optical fiber over a period of that will remain the only way of communicating all those big data for further analysis. So this is the preface of my talk. So having all those, the content will be the green sustainability optical communication, and just also the energy efficient communication methodologies, which will be reducing our power requirement, our energy requirement, and for all those things. And then summarizes the specific green photonics technology. The green photonics these are buzzwords. Green photonics is becoming very important, along with all those data analysis. And then assess the current and the potential future markets, which is the new new type of the materials are coming, new type of the architecture design is coming, new type of the application layers are coming. Things. The platforms remain the same, but the implementations are going on changing with a lesser and lesser energy being used for that. That will be the for the sake of the paucity of the time, I may skip, but for the continuity of for the sake of the continuity of my talk, I may go through that, but it will take a smaller time, but because it may take a longer time for explaining everything. It will the introduction of greenness, and then the energy consumption and the optical in the all the type of the network, maybe a copper-based network or a radio-based network and an optical fiber-based network. I'll make a little comparison in terms of the energy being taken, and the energy efficiency in the optical network and the energy-aware optical networks. How these things can already make intelligence that which path will be the way the minimum energy will be required for passing the maximum information. And then the introduction will be I will not go through all those things because this is all the. I'll come to the introduction part. The energy efficient approach I will just explain, and energy awareness approach. These are the two approaches under the researches going on with this, particularly in the Bell Lab, and how can we make the ad hoc type of the network which takes out the best possible of all the nodes which consume the lesser energy, and what should we do? What you call the deep sleep or the awaking phase, and all those things. Various types of the permutation combinations are taken care of. So that in the network itself, the design is so much that the minimum energy is being consumed for that, and I will just compare for that also. Now the green. What is called the green? As I said to you, as for the sake of the continuity again, the green consumes. It's consumed less non-renewable energy. Non-renewable energy means the coal, the petroleum, the diesel, and in the form of electricity, and these are cannot be changed, and produces the less polluting toxic material, greenhouse gases, maybe all those things, because after all the greenhouse gases make such an impact of that it absorbs energy, radiates back to that, and is responsible for the global warming. And that's why more and more production of the global warming may come. And again, the motivation of this talk is to the greening the telecommunication is to how to reduce the cost of the operation of the telecommunication in terms of the energy being consumed, and to expand the network, because in the country like ours, where the 70% of people are living in a country area or the rural area, we have to make a reach of all the telecommunications in their reach where the power is not available. So how the power, those facility of telecommunications, the broadband, or all these big things which we have been discussing since morning can also be benefiting to the rural people also. So we have to transfer all these benefits of all those things which we have been studying in ICT platform to the rural also people also. So how can we do all those things? And then also the sustained development goals says that we have to use a more and more green part of that. And particularly in the telecommunication also, how this is a more relevant. And the estimate law, let's have a few minutes on this. I'm not talking about so many things. I'm just talking about a mobile part, that too, only on the tower part. It's a big spectrum of the telecommunication as a whole is there. But if we see only to the part of that, let's say how much carbon dioxide is being produced, which we are not, because the nature has a process of nullifying it, so we do not understand the importance of all those things, estimating the carbon dioxide or the greenhouse gases. Let's say the 40% of the power of the roughly 40,000, maybe more than that, this figure is a little older. 40% of the power requirement. And finally, if you see that the total consumption is 2 billion liters. If you see in the rural area where the electricity is not there, they use the diesel for running all those towers and other things. And it takes about the 2 billion liters and 5.3 million liters of carbon dioxide is produced. And then for every watt hours, a grid electricity consumed 0.84 kg. I mean, it's an estimation of the carbon dioxide. So if you take all those arena, all those gamut of the things in the telecommunication, we can understand how much carbon dioxide being produced. Not only carbon dioxide, but other gases, what you call the greenhouse gases. How this telecommunication and particularly the optical fiber is going to take care of things to a little extent, not to the all extent. And then the sustainability, I say, what is called the sustainability? Because the word sustainability came over here. Sustainability means making our life comfortable today also without injuring the comfort level of the future generations to come. That's called the sustainability. Any technology, any business will be progressing only when it is sustainable. And sustainable means we are not injuring on the prospect of the future people. No. So if I consume all the non-renewable energy today, nothing will be left for the next generation. For the sake of the things, 3% of the total energy being consumed is taken in the telecommunication part. It's a huge amount of the energy being taken, and then the huge amount of the pollution being created. So this is the green optical fiber. Again, I'll continue with the green if it generates again. They say, now the green photonics part. Green photonics is not only the optical fiber, but also the material and the component, and also the design of and how the people are making the application of that, putting all together in a photonic era, because in electronic and photonics, electronic consumes much more energy than the photonics. So if we just move from making the things in a more from electronic to photonics, lesser and lesser energy will be used. How it will be done? I mean, we have the LED, say for in the laser or in the LED part of that, various OLEDs are being used. Organic light emitting diodes are being used. And I will just come to that if time permits that. How the OLED are being used for these things, organic and the new energy and the communication technologies, new and optical sensors. They are also the part of the whole new photonics. And then the clean manufacturing, and that's not only the operation part. From taking the greening of the telecommunication, it starts from the manufacturing itself, and then the operation, and then the applications. Whole process is made green. Green means consuming less, emitting less. These are these are the major areas where we have already done this. This is if you saw only the photonic production by the sector. If you just see the two sectors, in the communication 6% and ICT consumes 18%. So it makes about 25%, 1/4 of the whole lot of this is taken by the telecommunication aspect, particularly the data aspect and all those things, and data production and the communicating it for further applications. For sake of all those who are not little aware about that, let's see our network. Network consists of 3 parts. One is the core, another is the metro, third one is the access. Core is the part which plays a role. Say if I go for a international communication, then the part of the telecommunication network is the part of the core, or also in the nation itself. Also, it is somewhere it is called the ILD and then the NLD. NLD, ILD means the international long distance communication and the international long distance. And then particularly the last part which delivers the service to the customer, end customer, is called the access network. Let me see the design of that, and then we'll see which part is consuming how much of the energy of that. And this is and not only the connectivity, but also the speed required vis-a-vis the applications. If I go for a various applications which are talking today, how much the bandwidth is required? How much the bandwidth is required? You see, and that is, I mean, if we go simply by 2020 or 2030, by simple analysis, we can go. Each and every home will be requiring at least 100 Mbps. And in India, you can understand, if the 100 Mbps are required for all those applications which will be available by 2030, which we are envisaging, and all those talks have come like that. And then we can very well imagine how much the bandwidth will be required. And if the bandwidth is required, every bit wants an energy, every bit. If I say 256 kbps, some different energy required. If I say 1 Mbps, if I say 10 gigabit, 40 gigabit, or terabit, or zetabit, whatever it may be. If those, then every bit, and there is a simple correlation also, the every bit consuming how much energy and how much pollution being created. And this is the beauty of this particular study. This is the particular. I mean, if you go through only for the applications part, not caring of the things, a havoc may be created later on. So we have to be very, 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 very cautious. You see, a glass of water. Thank you very much. You've always been benign. Sorry. So you just see how the energy being, I mean, it's an analysis coming out in the IEEE communication sector. I have taken this one. Is the over 2005 or 2009 to 2017, you see is a straight line and is doubling. In the span of less than 10 years, I mean, about the 10 years or less than 10 years, the energy requirement is doubled. We can, and we if we keep it, the bit required, applications bit required, technology being serving those bits, and then energy required. And if the proper steps are not taken, we can understand where we are going. I'm just giving the futuristic aspects of these things, that how much important this aspect vis-a-vis all those applications which we have been discussing today. The implementation issues is one thing, and then again the requirement issues, the further requirement issue will be entirely different. It's a big study, and these are the only outcomes. I've got the own studies of those things, how these things can be done. And I was just said to you that each calorie being created somewhere is getting converted into data through a network, through analysis. So that's why there is, as I said to you, the correlation between data out and the energy being produced. So whatever the data required, you have to require the energy also. And for the energy, you need coal, you need diesel, you need petrol. And they are not the limitless sources. They're not the limitless sources. They have the end point. And if I consume all today, what my children will say to me, what have you done for your benefit? You have consumed everything for yourself. So that's why this study is very relevant. Again, the optical networks have a huge bandwidth, say the core network, because the aggregation, if you say everyone is having 100 Mbps, how much the core will be requiring now? You can understand. And when the core is then if you have a comparison with the other technologies, say copper and radio, then we can understand for propagation of the same bits, copper needs much more power than the optical fiber. I will tell you how. Very easy. I mean, those who have studied the communication part, it's not to be explained. And issues then, they're estimating energy consumption, the network, where does the energy go, core, metro, or access network, or what will happen if the traffic goes over time it goes. But the source itself is not going over and over and over and over. So that's why the greenness is, the CAN optical and photonic technology help to build a green network, that's called the optical. But making prediction for this is entirely a very difficult phenomenon, it's a very difficult proposition. So no, this part, so this is a graph between a product performance and also the applications aspect. You need how much the percentage of the data and how much the percentage is increasing yearly. And if it is a straight line propagation, we can understand what is the destination. So this is the simple network evolution which I told to you. This is a core network where at least a wavelength division multiplexing type of the network is required, and then it comes to the metro network, where we need, say, 622 or 140 Mbps. This is, and STM4, STM16 is required, or a coarse DWDM is required. And the final part, which connects the last switching point to the customer, is called the access network. This is of the different time. Sometimes it is copper-based, predominantly in India, with the BSNL and MTNL, they are having the copper itself, So the broadband has to be put on that only. But that's the copper part, and the bandwidth is to be put, then for the ADSL, through ADSL or VDSL we go, and then the part of another is the wireless, putting the 3G, 4G, and now the 5G is and the LTE and LTE advanced. But the type of the bandwidth which will be required by the customer today and tomorrow, these technology may not be able to deliver with greater reliability, flexibility, upgradability, manageability, and sustainability finally. Therefore, what we require is further moving for all those characteristics of a network. That for also we require the movement towards the optical fiber, and that through green. That actually justifies the topic of my talk. In case when so much the data is getting generated, and then the final delivery is done, what will be the media for that? And this is another part of that, the energy model of that. The core network is mostly an optical fiber through the various optical cross connects and the core router, and further also and then also the metro network is also at the same time, but is smaller in number, etc. And finally, the access network part is either through ADSL or through the OLT or the switches, metro Ethernet switches, what you call MEN, and all the final delivery is done through that with all those applications, or the bandwidth hungry applications will be delivered finally. And this is the energy per bit, how the MEMS is the micro electromechanical switches, and also the optical amplifiers, EDFA, ADBM dot fiber amplifiers, and then the photonic ICs, not the electronic ICs. The miniaturization, at the morning it was told, miniaturization will be much more intense as compared to the electronic integrated circuits. So the photonic integrated circuits will be developing and taking lesser energy, so consume lesser energy. And then the Ethernet switches, and finally, when these things come, and I will not go into the detail of wavelength, sub-wavelength aspect of this, because that will a little more technical detail. But if I just make a comparison between having the same port count, how much, if I put the same copper delivery through a copper, and if I deliver with an optical fiber, then how much energy, you see at the 288 port, if I deliver the same information through a copper network, then it is roughly about 3 times as compared to the optical fiber. Why? Can anybody answer? Why? Pardon? Yes, because I will just give you the example what is optical fiber? Optical fiber is hair thin, you know. And limitless information can pass through that. What a human being can think today or may not think today, may think even not tomorrow, that much information can be carried by a human hair's thickness optical fiber. But if the same information is to be carried through an optical fiber, I mean, this much of the width is required. This will make the comparison. And if only the thickness of the media is required, then you can understand even the corresponding energies, corresponding connectivity, corresponding repeaters, amplifiers, regenerations will be required, and that will consume a lot of energy. I'm coming every time. That day, the optical fiber is already carries the data equivalent to the 1,000 copper. I mean, at least 1,000 is saying that 1,000 is very say, but it should be